All right, today we're going to work on solving inequalities. If you know how to solve an equation, you can totally solve an inequality. They work the exact same way. So let's just do a comparison. I have 5x plus 7 equals 92, and 5x plus 7 is less than 92. So to solve an equation, we're going to isolate our variable, and we need to get rid of the 7. And the opposite of adding 7 is to subtract 7 from both sides of the equal sign. That's the same as what we would do for an inequality. To isolate the variable, we would subtract the 7. That would be our first step. Okay, so on both sides, we're left with 5x equals 85, or 5x is less than 85. So 5 times what is 85? So the opposite of multiplying by 5 is to divide by 5. Same over here. Even though there's an inequality, the opposite of multiplying by 5 is to divide by 5. And that's how we solve. 5 divided by 5 is 1. I'm left with 1x. 85 divided by 5 is 17. Same thing over here. The 5 divided by 5 is 1. I'm left with x. And 85 divided by 5 is 17. And our symbol stays the same. So x is less than 17. That's all we have to do. Well, that's almost all we have to do. So there's one little hang up, and it's your negative signs. But still, solve the inequality the way you normally would do as if it was an equation. So don't let any negatives stress you out. That's okay. There's negatives in the problem. You just deal with them the way you would if it was an equal sign. Here's your trick. The only time you change the direction of the inequality symbol is when you multiply or divide by a negative. That's it. So you'll change the direction. So if it says less than at the beginning and you go, oh, I needed multiply by a negative, then you switch the direction to the opposite way. So again, it doesn't matter if there are negatives in the problem or the answer. The only time you change the direction of the inequality symbol is if you multiply or divide by a negative. So let's give this a shot. Okay, let's practice. Yeah, ready, work it out. Work it out. We have 7x plus 5 is greater than negative 30. All right, goal. Get x alone. All right, well, it's 7 times x, so I need to get rid of my plus 5. The opposite of adding 5 is to subtract 5 from both sides of the inequality symbol. So on this side, I'm left with 7x, and I have negative 30. Take away 5 is negative 35. Still trying to get my x alone. 7 times what is negative 35? Well, the opposite of multiplying by 7 is divide by 7. 7 divided by 7 leaves me 1x. Negative 35 divided by 7 is negative 5. And wait a second, there's a negative here. But it says greater than, greater than, greater than. Why would I leave it as greater than? The direction of the inequality didn't change because we didn't multiply or divide by a negative. It doesn't matter that there are negatives in the problem. It only matters if as I was solving it, that I multiplied or divided by a negative. I ended up dividing by a what? Positive. Okay, new problem, number 2. I have negative 7x plus 5 is greater than negative 30. I can tell this is a totally different problem. How would we solve it to get x alone? Well, we need to get rid of the plus 5. The opposite of adding 5 is to subtract 5 from both sides of the inequality. So I'm left with a negative 7x on my left and a negative 35 on my right. Still, it's greater than. How do I get x alone? Well, I need to divide. Divide by negative 7. So I divide both sides by negative 7. And negative 7 divided by negative 7 is a positive 1x. Negative 35 divided by negative 7 is positive 5. Whoa, it went greater than, and now it is a less than. Why did I change the direction? The direction of the inequality changed because we divided by a negative. That's why it changed. So obviously these problems were almost identical, but in problem number 1, we divided by a positive, so we don't have to change the direction. But in problem 2, I divided by a negative, and so yes, you do have to change the direction of the inequality. And if I were to graph this for you, I could explain the whole theory and philosophy as to why you have to do that. So if you want to know that, just email me. Okay. Ooh, check this booger out. All right, we have x take away 3 divided by 2 is less than negative 5. My goal is to get x alone. It's in the numerator. I can't just take away get rid of that takeaway 3. I first have to get rid of the divided by 2. So the opposite of dividing by 2 is to multiply by 2. So I multiply the left side by 2, and look, 2 divided by 2, they'll cancel out. Multiply the right side by 2, and so I'm left with x take away 3 is less than negative 10. And how do I get my x alone? Well, the opposite of subtracting 3 is to add 3 to both sides of the less than sign. So that leaves me x, because negative 3 plus 3 is 0, so I'm left with x is less than, and negative 10 plus 3 is negative 7. It says less than, so it went less than, less than, less than, less than. Why would the answer stay in that same direction? Because we didn't multiply or divide by a negative. Ding, 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 ding. We're catching on. What about number 4? Check out number 4. Ooh, it got a little more complicated. 6, take away 2x divided by 3 is less than 4. I don't even think we have negatives today. All right, well, in order to get x alone, I first have to get rid of this great big divided by 3, and the opposite of dividing by 3 is to, you guessed it, multiply by 3. So I multiply both sides of my inequality by 3, and that leaves 6 take away 2x on my left. And what do we get on the right? 12. So 6 take away 2x is less than 12. Need to get my x alone. All right, well, this is positive 6, and to get rid of a positive 6, you have to do the opposite. And the opposite of positive 6 is to subtract 6 from both sides of our inequality. So 6 take away 6 is 0, so I'm left with this takeaway, or negative 2x, and I have 12 take away 6, which is 6. So it's still less than. Now to get x alone, the opposite of multiplying by negative 2 is now I need to divide both sides of the inequality by negative 2. And negative 2 divided by negative 2 is positive 1. 6 divided by negative 2 is negative 3. And did you switch the direction of the inequality? Now, why would you switch the direction of the inequality? Come on. Any reason why? Because we divided by a negative. That's why we'd switch the direction of the inequality, is anytime you divide by a negative, you've got to switch the direction. Or if you multiply. Okay, well, these problems weren't that hard. What about this one? Dun 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 dun. Number 5, the final problem of the tutorial. Okay, we have a gigantic numerator divided by negative 4 is less than or equal to 44. Okay. Well, our goal is to get these x's alone, and there's a couple ways you could start this problem. You could combine like terms, but I'm just going to get rid of the denominator. And how do I get rid of a divided by negative 4? Yeah, I multiply both sides of the inequality by negative 4. So that way negative 4 divided by negative 4 just leaves me my 5x plus 18 take away 3x less than or equal to 44 times negative 4. And oh, did you see what happened in the middle of the problem? Because I moved my negative 4, I multiplied by a negative, the problem is no longer less than, it is now greater than or equal to. Big difference. So whenever you multiply or divide by a negative in a problem, that's when you switch it. So now we'll just combine like terms. I have 5x take away 3x, which gives me a 2x plus 18, greater than or equal to negative 176. How do I get x alone? Got to get rid of my 18. The opposite of adding 18, we subtract it from both sides of the inequality. So I have 2x is greater than or equal to negative 194. Now I have 2 times x, so the opposite of multiplying by 2 is to divide by 2. 2 divided by 2 is 1. Negative 194 divided by 2. Now will we change the direction again? No. X is greater than or equal to negative 97. The last step we divided by a positive. The only time you change it is if you multiply or divide by a negative. So I hope this helps as you continue to solve inequalities. Keep it up.